Assalamualaikum warahmatullahi wabarakatuh and very good day. Welcome back to the series of half-wave rectifier uncontrolled with R load. We're using the MATLAB release 2012A to analyze our half-wave rectifier uncontrolled with R load. So before we begin to the series of this video, this is the third video of the analysis of half-wave rectifier. I would like to recall back our previous video on the second video showing that the simple analysis to calculate the mean value, or what we always call in the class as a average value. Okay, so in this video I would like to demonstrate the next parameter that we want to obtain is RMS value, root mean squared. So if we maintain the block mean in this schematic diagram, we need to find the block RMS by searching at the Simulink library browse by typing RMS, enter, and then you will have the display from the Simscape frames the discrete RMS value and RMS. So I choose RMS block parameters and then add to the file. Okay, we resizing the RMS and just a little bit so that we fill in the view. Okay, then I put here, since we need to calculate RMS output voltage and RMS output current, so we need to have two blocks. Okay, we copy another block. We just put here, and then you have two options to display the output RMS output voltage and RMS output current by using the similar scope, or you want to have the another scope. So we do the first step. We do the first part, that we use the another block. Okay, by making another block of the scope, and then we do a connection. Alright, and then this is for the output current, this is for the output voltage. Okay, so and then we click the start simulation with the remaining simulation stop time at 0.06 second. Okay, okay, after that, if you double click at the scope for output RMS output current, we have a look at the steady state value. I forgot to mention that the value that we calculate in the class is obviously on the steady state value. Okay, what I mean is the steady state value is the value that will display the constant value for the output results. So this is the output for the current. We obtain a 3.1 something. Okay, RMS value 3.1 something. So if I go back to our slides for the calculation, okay, we obtain the output RMS at the 3.11 ampere. Okay, similar what we obtain with the simulation. Okay, so and then we go back to the schematic diagram and try to look at the our RMS output voltage. We double click, we search for the steady state value, we draw here, we obtain at 77.8 or 77.7 something. Alright, this is the scale for 77.8. we just normally obtain at nearly 77.8. so go back to the slides, we obtain at 77.78. okay, so we get the value exactly with the calculation in the class. So this is the first type that I want to show to you, with the different scope that we can obtain. Another type that I want to demonstrate to you is by using the one scope but different axis. So I remain the scope for the mean value as well as the mean value for the output voltage and mean value for the output current. So you double click at the scope and then we go to parameters. Oops, wait here. Go to parameters. Cancel back. Go to output voltage. Okay, we go to the parameters. What we call here, we want to have the parameterizing simulating block. Okay, so I want to have the parameters. Okay, number of axes. If you seen the default value for number of axes in one scope is 1. So in order to have two axes, you need to put in order to have two channel in one scope, you need to put number of axes is 2. Then you click apply and OK. So sorry for the delay, and then you will obtain the two channel here. So this is the second axis that you can put the RMS value. So similar with the first scope, go to axis, parameters tab, and then go to number of axis, you put OK, close back. Sorry for the delay. If you put at the first axis, meaning that the output results will put at the first axis. Okay. you put at the second axis, and then we will put at the bottom. Okay, save, and then we do the start the simulation. This is what we have. Okay, this is for the output RMS value for the output current, and this is the mean value for the output current. If you want to do the labeling, simply you can do the labeling for the block diagram. So for example, I want to put the here, you just double click at the line and put the, let's say, RMS output current. Okay, and here you double click to put RMS underscore output, average output current. Okay, then we put here, want to do the fit to view. RMS voltage output voltage. Okay, then we put the, say we put here mean, average, just to make a consistent in our terms. So this one is RMS output voltage. Okay, and then we need to save and start the simulation again, and then we can found it here. So auto scale still doesn't show any legend, so we need to go the parameters again. Put legends and apply. Sorry for that. This one also we need to put axis, parameters, and put legends, apply. Okay, see, there is a shadow here. So there is a title here showing the labeling of the different parameters. Okay. Okay, let's say you want to have, this is the third type of the scope. Let's say I want to have the scope to remain as exactly with the one axis. Okay, this is the third part of the how to arrange your scope. Okay, you can delete this one channel. Let's say I want to have the to remain one axis, just to remain one axis. Remain one axis, and I want to put two parameters to the one scope. So how I want to do that? So we need to have another parameters called multiplexer. You go to the Simulink library, browse, you type MUX. Okay, we have the multiplexer here. We have 2 input and 1 output. Okay. Okay, and then we copy the block. If you want to do the automatic connection, you just click the one block and then press the control button and then press the another block. Sorry. Okay. Okay, now we do the simulation again. This is what you get for the third type of doing the connection for the one axis with 2 input of the parameters. Okay, this is for the output voltage, so you can control the legend of the results. Okay. Okay, the next analysis that I want to demonstrate is by using the simplot command. So what is the simplot command? Before we do the simplot command, we go back to the scope, we go to the parameters. Let me put at the okay, in the parameters window, you have 3. In my release 2012A, I have 3 tabs in my parameters block. Begin with general, history and style. Okay, and then you need to go to the history, put the save to workspace. Okay, save to the workspace, maintain the format with structure with time, and I put here the variable name as the OPC, output current. Okay, just click OK. Then go back to the second scope, you do the similar setting, go to the parameters block and then go to the history tab, go to the save, remain the structure with time, and then go to OPV. The variable name is up to you, you can name it as you like. The more shorter, the easiest you can recall back the name. Apply, click OK. Okay, now we go to the start of the simulation, and then we go to the command window. If your command window have messed up with messages, to work in the proper strategy, you need to clear CLC clear. Okay, this is I want to share with you the command of the simplot. Simplot, type the simplot command and then open bracket, you type the variable name, let's say OPC, one of the parameter variable name that I put in the output current. Just enter and then it will display a pop-up window. Okay, this pop-up window. In this pop-up window of the new configuration of the output current, you can adjust and modify based on your needs. Okay, for example, we go to do the this is begin of the editing process. Okay, go to edit and then figure properties. I want to remove the shadow background to put the figure color. Okay, go to bring your cursor to the background of the black display. Go to change to white color. This one is go to black. Okay, and then if you want to have the title, this is for the x-axis, isn't it? X-axis meaning that this is a time in second. Okay, it's time in second. So if you want to y-axis, this is the current. In M. Okay, no y-axis. Sorry, this is time. Here, put here time. The title, this is what we call as what's the title? The title is a output current for half-wave rectifier uncontrolled with R load. Still not appear here, so you need to search here, click there and put black. There you are. If you want to change the thickness, you just double click at the line and then double click at the thickness, double click at the line and change according to the size that available. Okay, here you are. And then if you want to copy this to the window, to the Microsoft Word, what you need to do is go to edit, copy figure, and then you open the Microsoft Word. I always recommend students to use the this technique in order to put into your report. Okay, so in Microsoft Word, what you need to do, you put the insert, go to shape and new drawing canvas. Okay, and then in this platform of the new drawing canvas, you just paste it, and then you can adjust the size of your waveform or your results. Okay, okay, this is for the end of my third video about the how to manage your RMS value, how to manage your scope, and how to put your results in the Microsoft Word. Until then, see you in the next video. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.